Welcome to another Tech Tuesday at FiTech, students. Today we're going to learn how AFR Learn and Trim work. .4,075 kPa's got a 65%, which is a minus 35% fuel learn. I don't know how accurate that is because it's very rarely going to be anywhere near that load condition. Let me see if I can get it on the dyno here real. So in the handheld, you can see the AFR right now is reading a little richer than target, so you're going to see the trim go down and then jump back as it reaches the target. The computer is trying to get the AFR to match the AFR target. The trim's going to jump up and down a little bit as it does that. And if there's any long-term correction needed, the learn will actually start learning. It adjusts the fuel by adjusting the fuel pulse width. So I showed you on the injector flow bench that the pulse width is what's changing the fuel flow rate. You can see on here the pulse width goes up and down just a little bit. It's based on engine RPM, map, coolant temperature, and then the fuel closed loop and trim, the fuel trim and the fuel learn are multiplied on top of the base calculation, and it self-corrects to try to get the AFR to match the target AFR. If there was some fault, such as a bad sensor, the AFR may just stay reading at 20.6 to 1. That would mean the sensor is defective. If it's running like this, it shouldn't read that. If the AFR sensor reads just 10 to 1, you may actually have something wrong with the fuel system. Maybe an injector is stuck on and just dumping fuel in all the time. So you can see AFR at idle is around 13.5 to 1. To see fuel learning as a whole, look in data logging, go down to the fuel learn values, and it'll read out the learn values at all the different load conditions. I notice I'm pulling a lot of fuel at the higher RPMs, lower loads. I may actually want to go in and correct that. I can correct that actually in Pro Tuning. On some models, I'll actually have a cam fuel table. I'm on cam 2. So at high RPMs, and that was at 3660 kPa. So these numbers may actually want to come down a little. I'm just going to make a quick correction here, and then I'm going to go back and check it. I'm going to go back and recheck where my data logging fuel learn values. So I was at 80%, 1850 kPa, 70%, 3035 and 50 kPa, a little bit down there. 4075 kPa, looks like I've got a little too much fuel. So I'm going to take both of these. So I'm not holding it at 4,000 low load very long, but I am going to be holding it at those loads for quite a while, and that load. So I may have a little too much fuel all throughout the higher RPMs. If you ever need to reset the fuel learn, you can do it in engine setup, set that to 1. Or you can set it in reset learn. You can reset all if you wanted to reset IAC and TPS all together, or just set the reset fuel learn to 1. Send that to the computer, and then turn the engine off. Now when we go back to the fuel learning, you'll see that it's all 100s. But in order to see it, I'm gonna have to turn the key on again. You can see on the fuel learning now they're all 100 after I've reset it. So I like to do that every once in a while if I've changed something, if I fixed any kind of faults, reset the fuel learn. If I've made some big changes to the fuel cam tables, resetting the learns may help you identify areas of the fuel table that need to be adjusted still. So I can see it's rich at idle, and it's gonna, my idle fuel learn's gonna start going down. Let me just start rolling in a little bit. You'll see some of the other sections of the map start pulling fuel. At 750 kPa, I can see my learn value is -5. I can make an adjustment to the fuel table. Let me just double check where I'm at. I'm on cam 2, 330 cubic inch. So I'm gonna go down here to cam 2. I'm in the 500 to 900 range here, so I can actually, that's 4%, 5%. Let's do a little more. So after that, I should be able to see that it's actually changed the fuel learn value a little bit. Yep, there we have it. So it's right around 0. 0 correction. That would be an ideal VE table, cam fuel table, where it's plus or minus 5 or so. But it doesn't make that much difference if it's plus or minus 10, as long as it's already finished learning. There is interpolation between the learning cells. So there you have it. AFR learning and trim is important for the system operation. That means you do have to run with your oxygen sensor all the time, but that makes sure your engine's operating at ideal conditions all the time and that the system can make all the corrections that it needs to do. If you don't have your oxygen sensor working properly, or if the trims are way far off, you may hear the engine stumble. It may have a little hesitation or smokiness if it's really rich, but getting those things dialed in right with the learning doing its own thing is fairly important for the operation of the engine. I hope you've enjoyed today's video about AFR corrections and learning. And if you have any questions or comments, leave them below. You can contact tech support if you really need any information. Hope you join us again next week for another FiTech Tech Tuesday.